Hello everyone, welcome to the European offices of Optohellas in Athens, Greece. My name is Dimitris Vasiageorgis. I'm Application Specialist and Biomedical Engineer by Optohellas.
Hello everybody, I'm Emanuele Lanterna, Business Director Europe and OCT veteran from TowardPi.
We want to welcome you to the first video tutorial of the Yalkaid Swept Source Ultra-Wide Field OCTA
manufactured by TowardPi.
In the first chapter, we will showcase you
the proper macula scan.
The first thing we will show you is how to create a new patient entry. When you open the software interface, the first screen you see is this screen right here, and it is automatically highlighted the button on the top left, Create Patient. You click on Create Patient, and another tab appears for inputting the patient data. First field is the ID of the patient, which is automatically inputted by the software. But in case you use a different patient ID system for your software or for your system that you are using, you can, of course, change it to your preference. The second field is to select the ethnicity of the patient. If you click on the arrow, you have a list of different ethnicities that you can select depending on your patient. And this selection will affect the normative database of the results after you do the examination. As always, you have to input the first name and last name of the patient. Select the gender of the patient and input the date of birth. If you input the date of birth, the age number on the top field will be filled automatically. In the last fields, you can also select for database purposes and to have a history, the axial length of the eye of the patient. And finally, in the bottom of the tab, there is a field to enter a free text for a comment regarding the patient, which might be some general comment to better remember the specific patient. Now we are going to the next step.
Now we are going to explain the best way to make an acquisition. We have the patient. With the chin rest, we have a reference mark for understand if it's in the right position. With the mouse, we jump in the scan mode, and with up on the left, we have the possibility to correct X and Y and go in center of the pupil. In the center of the pupil, then we move the head scan with the scroll to obtain the best SLO image. Now at this point I can click Full Auto. And now I have nice image here of OCT, correctly centered and a nice SLO image. I can press Capture and I can obtain a nice scan. And now we move to the second chapter. Now I'm going to tell you about line scan a bit deeper. We have the patient, and I will acquire in the same way. So my arrow, I go inside to obtain a nice SLO. I put Full Auto, and when the system here is ready, I can click Capture to obtain a line scan of 16 millimeter length and 3 millimeter deep. If I want to switch on the review, I can have the line scan. I can manage to show a little bit better the vitreous, or I can increase to see a better choroid. I can move to the segmentation, display all the segmentation automatically and driven by AI of the retina, and that's all. Of course, this is a 17 millimeter length with 3 millimeter deep. I can have even 6 millimeter depth, 9 millimeter depth, of 12 millimeter depth, according to which retina I need to scan. And now we move to the next step.
Now we are moving to the second examination of the macula, which is the cross scan. We press the scan button on the top of the image again to initiate a new scan. And from line scan, we select the cross button. Cross is actually a two-line scan. It consists of a horizontal and one vertical scan. Like the rest of the acquisitions in the Yalkaid, we can choose the depth 3 mm up to 12 mm. And by default, we have a length, the wide scan of the area 12 mm, but we can increase it if we want up to 17. Of course, you have the option to change also the direction, which is the angle of acquisition, and actually rotate the scanning lines. So, with the same principle as before, we use the top left of the screen to click in the center of the pupil, use the scroll of the button to have the best possible image on our SLO image below, and when I have pupil center SLO image very good, I press the full auto button for the device to automatically align the OCT, automatically adjust the brightness, contrast, and polarization of the image, and when it is ready, the capture button is released and I press capture. The acquisition is extremely fast, it is saved. I see in the preview screen my two acquisitions, and I press enter review to see the final result. Here I see I have the list of my two tomograms, the first one which is the horizontal, the second one which is the vertical, and on the bottom there is a thickness graph which showcases the retina thickness from the beginning of the image, from one edge of the retina to the other. This is the same also for the horizontal and also for the vertical scan. Now we are going to the next chapter.
Now I'm going to speak about the radial scan acquisition. So we have the patient, same procedure, X and Y, with the scroll Z, full auto, and I have set line scan 17 millimeter length, and as soon as I am ready, I can click the capture button and the system acquire 18 line scan that if I press review, I have all the 18 line scan available to be preview, or I can press the 3D button in which I have a line scan that I have selected shown on the SLO image. And now we move on the next step.
Now we are going to show you the macula grid scan pattern. We select Scan again, and we click on the next scanning protocol, the grid scan. The grid scan actually consists of many horizontal and vertical tomograms. 5 horizontal, 5 vertical. You have the opportunity to change depth, length, up to 17 ultra-wide scan, and also adjust the spacing between each of these lines. So you have the possibility even from 2 millimeter and 10. I click on the center of the pupil. I adjust the position by the mouse scroll to get the best possible SLO image. I press full auto for the device to automatically analyze, optimize the OCT image and the tomogram. And as soon as it's ready, I press capture. Here I have a preview of all my results, 5 horizontal, 5 vertical, a total of 10 images. I press enter review to see the results. And here I have the list of all my tomograms, 1 through 10. I can review each one. See in the bottom the thickness chart representing the retina thickness on each of the examinations. And with this scan, I can capture a very much wider area and have more high quality tomograms with good acquisition of the vitreous and the choroid. Now we move to the next chapter.
Now I'm going to speak about the raster. Raster acquisition, please. Raster acquisition, same, I do the X and Y and then the Z, full auto. I can go up to, even here, up to 17 length acquisition. And of course, I can move the raster in the place I need it. Not only in the center of the macula, but if I need to have something offset, I can offset the cross line, the cross in the fixation point, and I can use it to acquire. I move back on the center, and as soon as I'm ready, I can go in the center and acquire. So acquisition is done. Then I go to review, and I have all the acquisition preview that in the place I need to see better. You have the possibility to have a nice scan, and you have even the possibility to have some maps about inner retina, outer retina, or ILM and Bruch membrane. Of course, if I switch to the 3D, I have same in the radial. Even here, I have the possibility to have the line scan that I have pointed represented on the SLO. Now we move to the next chapter.
Now we move to the next acquisition of the macula, which is the 3D retina. In the scan page, I click on 3D retina. 3D retina is an area scan, which means that in a dedicated area, it will scan a great number of B scans in order to cover all this scanning window. This is adjusted by the length and the width. So the scanning window here will be a 6x6 acquisition, of course, which I can decrease or increase it quite a lot actually, up to 12x12 and more, up to 15 millimeters. Normal OCT, the basic OCT is an examination of 6x6, but because here we have the ultra-wide field OCT, I can do a 15x15 cube scan. The same way I click in this area on the center of the pupil, I see my SLO image to be in the best possible condition without many shadows, and I press the full auto button for the system to automatically adjust the best possible image that it can acquire. I can also move the image more down according to my preference to visualize the vitreous a bit more, and I press capture. The acquisition is done. Compared to the previous examinations, which I had 1, 2, or maybe 10 B scans, here I have a total number of 512. I press Enter Review to see the final result. And as you can see, in this examination, we have covered a very wide area and actually a very dense area. I have 512 B scans, and this allows me not only to not miss any detail between each scan, but the software automatically creates a reconstruction of the fundus surface, which is called the end face. So I can visualize the surface of the retina, but also visualize the surface of the inner parts of the retina, of deeper layers. That's why I have the possibility to click on inner, outer retina, and choroid. Please look, it is very important how clear and how well detailed it is the face image of the choroid and how fast we managed to acquire such a high quality face image. Now we move to the next chapter.
Now I'm going to speak about the 3D Retina 15x9. Let's acquire. Same procedure of acquisition. I press capture and it's done, okay? Now, clicking review, Retina 3D Retina 15x9 allows you to have a very nice screening tool because it's Retina map, and if I switch to eye health, I have a very nice screening even for glaucoma, because I can provide, because the width of the line scan, the retina thickness, the RNFL thickness, and the GMA, which is dedicated to ganglion sign complex. And it's able to give to the doctor the RNFL dimension of the nerve head. Now we move to the other chapter.
Now we are going to showcase you the final acquisition scan pattern on the macula, the 3D map. I click on map. You will notice on the map that the length and width are locked. You are not able to change them. This is because the map is the common OCT acquisition for analyzing the retina thickness and providing a map to compare the results with the normative database that is in the software of the device. We'll make an acquisition by again clicking on the center of the pupil, adjusting with the scroll button the SLO image, and pressing full auto so the device can adjust all parameters like focusing, polarization, and central of the camera with one click. We press capture. The capture is done extremely fast. We have a total of 320 B scans. We press enter view. And we see the screen with the final result. As in the previous examinations, I have at the bottom all the 3D scans I acquired, all the B scans, from top to bottom. It covers the area of 6 by 6 millimeters, but here on the right side of the screen, I have the most important value, the retina thickness map, representing each area, the central macula, the periphery, the paracentral area, and the periphery of the macula, and shows me the retina thickness in each of these parts. I have two numbers in this map. The top one is the retina fovea distance, the retina fovea thickness, ILM membrane to Brooks membrane, and the small number in the bottom is the choroid fovea distance, from Brooks membrane to CSI membrane. Thank you for watching the first chapter of the tutorial of the Yalkaid swept source ultra-wide OCTA.
Stay tuned for the next chapter.